3, probability and odds. So when we're uncertain about the occurrence of an event, we can measure the chances of its happening with probability. For example, there are 52 possible outcomes when selecting a card at random from a standard deck of playing cards. The set of all outcomes of an event is called the sample space. A desired outcome, drawing the King of Hearts for example, is called a success. Any other outcome is called a failure. The probability of an event is the ratio of the number of ways an event can happen to the total number of outcomes in the sample space, which is the sum of the successes and the failures. So, if an event can succeed in S ways and fail in F ways, then the probability of success is S over S plus F. Probability of failure is F over S plus F. To determine television ratings, Nielsen Media Research estimates how many people are watching any given television program. This is done by selecting a sample audience, having them record their viewing habits in a journal, and then counting the number of viewers for each program. There are about 100 million households in the US, and only 5,000 are selected for the sample group. What is the probability of any one household being selected to participate? So the success is being in the sample group. There are 5,000 successes, and the failure is not being selected to participate. And so the total number of events is this 100 million. 2, 3, 4, 5, 6. So our probability of being selected to participate is about 5,000 out of 100 million. Or if we reduce that, 5 out of 100,000, or 1 out of 20,000. A bag contains 5 yellow, 6 blue, and 4 white marbles. What is the probability that a marble selected at random will be yellow? So we have 5 yellow marbles, so 5 successes out of how many total, right? 5 plus 6 plus 4 is 15. So our probability of selecting a yellow marble is 5 yellow marbles out of the total 15 marbles, which is 5 out of 15, or 1 out of 3, not 1 out of 5. I definitely meant that to be 1 out of 3. There. What is the probability that a marble selected at random will not be white? So same thing, we want the number of not white marbles out of the total number of marbles. And there are 11 not white marbles, 5 yellow and 6 blue, and 15 total. A circuit board with 20 computer chips contains 4 chips that are defective. If 3 chips are selected at random, what is the probability that all 3 are defective? So what we want to do here, and we're going to talk more about independent and dependent events in the next section. But we're going to do the number of ways that we can pick 3 chips out of 4 over the number of ways that we can pick 3 chips out of 20. Right? Combination, because we're taking 3 all at once. The order doesn't matter because the chips are interchangeable. But so the probability that all 3 are defective, right? This is the number of ways, the numerator here is the number of ways that we get 3 defective chips. And then the denominator is all of the ways that we can pick 3 chips out of 20. So groups of 3 chips. So our probability is going to be the number of ways we can have 3 defective chips out of the total number of ways that we can pick 3 chips. And so we use our combination formula. Remember this from 13.1. And so the combination of 4 choose 3 is going to be 4 factorial over 1 factorial, 3 factorial. And combination 20 choose 3 is going to be 20 factorial over 17 factorial, 3 factorial. And remember, when we're doing fractions, we're going to keep change flip. So we're going to flip this fraction here. And so this is going to have the 17 factorial, 3 factorial on the top, and the 20 factorial on the bottom. You cancel out the 3 factorials. 1 factorial is just 1, so I'm going to go ahead and get rid of that as well. And so that gets us 4 factorial, 17 factorial over 20 factorial. And so this is 4 times 3 times 2 times 1 times 17 times 16, blah, 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 over 20 times 19 times 18 times 17 times 16, blah, blah, blah. So these 17, 16, blah, blah, blahs cancel out. And we have 4 times 3 times 2 times 1 over 20 times 19 times 18. And we can simplify this a little bit more. 4 over 20 is 1/5. 6 over 18 is 1/3. And so we get 1 over 5 times 3 times 19, which is 1 over 285. If you're thinking, hey, isn't there another way to do this? There is. We'll talk about it in the next video. The sum of the probability of success and the probability of failure for any event is always equal to 1. This is often used in finding the probability of events. Right? So the probability of drawing the King of Hearts from a deck of cards is 1 out of 52. So the probability of not drawing the King of Hearts is 1 minus 1 over 52, which is 51 over 52. And if the sum of 2 events is equal to 1, then these events are called complements. It's complements with an E, not an I in the middle. The Cyber Toy Company has determined that out of a production run of 50 toys, 17 are defective. If 5 toys are chosen at random, what's the probability that at least 1 is defective? So, at least 1. If we're picking 5 toys, at least 1 could be 1, or 2, or 3, or 4, or 5. So we could find the probability that exactly 1 is defective, and exactly 2 is defective, and exactly 3 is defective, up to 5, and we could add all those probabilities up, and that would be the probability that at least 1 is defective. But that would take forever. So let's see if there's an easier way that we can do it. So out of 5 toys, right, the possibilities for the number of defective toys are 1 or 2 or 3 or 4 or 5 or 0. So 0 to 5 is the sample space. That is all of the possible values that we can get for the number of defective toys. And so the probabilities all add up to 1. But what we're looking for is this, right? This is our probability for at least 1, and then this is the probability of 0. So what we get is that the probability of no defective toys plus the probability of at least one defective toy add up to 1. They are complements. Either there are none or there is at least 1. So if we are trying to solve for the probability of at least 1, we can do this by subtracting the probability of 0 from both sides. And so we get that the probability of at least 1 is 1 minus the probability of none. And it's much easier to find the probability of no defective toys than it is to find the probability of 1 or 2 or 3 or 4 or 5 defective toys. So let's start. Calculate this probability of no defective toys, right? We have 17 are defective, so 50 minus 17 is 33 not defective. And so the probability of 5 not defective toys, right? 0 defective toys out of 5 is going to be the number of ways that we can choose 5 non-defective toys out of 33 over the number of ways that we can choose 5 toys out of 50. And so we can use our combination formulas here, right? This is going to be 33 factorial over 33 minus 5 is 28 factorial, 5 factorial. And this is going to be over 50 factorial over 45 factorial, 5 factorial. And so we can simplify this. We can keep, change, flip. And so this is going to be 33 factorial over 28 factorial, 5 factorial times, flip the second fraction, 45 factorial, 5 factorial over 50 factorial. Your 5 factorials you can cancel out. 33 factorial over 28 factorial. Remember, the 28, 27, 26 cancels out. So this is 33 times 32 times 31 times 30 times 29. And 45 factorial over 50 factorial. The 45 on down cancels out. And so you get 50 times 49 times 48, 47 times 46 in the denominator. So you're going to get 33 times 32 times 31 times 30 times 29 over 50 times 49 times 48 times 47 times 46. At this point, you can put this into your calculator. If you try and put this into your calculator may have some difficulties dealing with big numbers like 50 factorial. And so if it can't calculate 50 factorial, it might give you an error. So that's why we can, if we can simplify our factorials down to something like this, and then we can put this in our calculator and see what we get. This makes a really horrible, awful fraction, so we're going to leave this one as a decimal. It's about 0.11. So that is our probability of no defective toys. So our probability of at least one defective toy is 1 minus the probability of no defective toys, which is 0.11. 1 minus 0.11 is about 0.89. So our probability of at least one defective toy is about 0.89. Another way to measure the chance of an event occurring is with odds. The probability of success of an event and its complement are used when computing the odds of an event. So the odds are the probability of success over the probability of failure. Probability is the successes over the total. Odds is successes over failures. Katrina must select at random a chip from a box to determine which question she will receive in a mathematics contest. There are 6 blue and 4 red chips in the box. If she selects a blue chip, she'll have to solve a trigonometry problem. If the chip is red, she will have to write a geometry proof. What is the probability that Katrina will draw a red chip? So probability is going to be success over total. So there are 4 red chips in the box. Over the total, 4 red plus 6 blue is going to be 4 over 10, or 2 out of 5. What are the odds that she will have to write a geometry proof? Which, if the chip is red, she has to write a geometry proof. So the odds of the chip being red. Odds are success over failure. So the successes are 4 red chips, and the failures are the 6 blue chips. So her odds are 4 to 6, or 2 to 3. And a lot of time we write it as a ratio, like 2 to 3, or 2 to 3. "12 male and 16 female students have been selected as equal qualifiers for 6 college scholarships. If the awarded recipients are to be chosen at random, what are the odds 3 will be male and 3 will be female?" So, again, using our combinations. So when you have a complicated something like this, it's usually easier to find the probability first and then use that probability to find the odds. Because we don't, off the top of our heads, know the number of successes and the number of failures. So, the number of ways that we can pick 3 males from 12, going to be combination 12 choose 3, times the number of ways that we can pick 3 females from 16, combination 16 choose 3, over total the number of ways that we can pick 6 students out of 28. So we do our combination formula, 12 factorial over 9 factorial 3 factorial, and this is going to be 16 factorial over 13 factorial 3 factorial, all over 28 factorial over 22 factorial 6 factorial. And we can keep change flip this. Two factorial 6 factorial 28 factorial, and see what we can cancel here. So the 12 factorial over 9 factorial is 12 times 11 times 10. And the 16 factorial over 13 factorial is 16 times 15 times 14. And we've got a 3 times 2 times 1 times 3 times 2 times 1 down here. And then 22 factorial over 28 factorial. We're going to keep the 6 factorial up here. And then the over the 28 factorial, which is going to be 28 times 27 times 26 times 25 times 24 times 23. And then we see what we can cancel. We can cancel a 3, 2, 1 and a 3, 2, 1 here. That 3, 2, 1 makes a 6, so that also goes away. 28 could be 14 and 2. 25, cancel a 5 there. 24, we could cancel a 12 and a 2. maybe the best that we can do. We can cancel a 5 out of the 10. Cancel a 3 out of here. Can cancel 13. Cancel that too. So we get 11 times 16 times 5 over 9 times 13 times 23. That's 880 over 2,691. Now remember, this is the probability. This is the success over the total. We want the odds. So if the total is 2,691 and the success is 880, then our probability of failure is going to be 1 minus 880 over 2691, which you turn that 1 into a 2691 over 2691, and you get 1811 over 2691. So then your odds are success 1880 over 2691 over 1811 over 2691, and the 2691s cancel. It's going to be 880 over 1811. And just how odds are used in real life. This is a list of the horses competing in the Kentucky Derby coming up in a few weeks. It's the first Saturday in May, I believe. And so for betting on horse races, you can see some of these I accidentally have in here twice, but for betting on horse races, you can, the bets are given in terms of the odds against the horse winning. So, for instance, Arabian Night, the odds are 9-1 against that horse winning. So the odds of that horse losing are the probability of that horse losing is 9 out of 10, meaning the probability of that horse winning is 1 out of 10. And you could go through these, the probability that Practical Move wins is 1 out of 12 plus 1, which is 1 out of 13. And so you could do this for any horse. The current favorite here appears to be Forte, with odds of 3-1, meaning that there's a 1/4 chance that this horse will win. And so this is important for betting on horse races, because the odds affect how much money you win. If you bet on Forte and Forte wins, you get 3 times what you bet. If you bet on Arabian Night and Arabian Night wins, you get 9 times what you bet. So horses with higher odds against winning will earn you more money if they win, but you are less likely for them to win. And that's it for 13.3. Tune in next time for 13.4, Probabilities of Compound Events.